Okay, so welcome everybody. Since this week we are starting a new series, you can say that solve last week's contest problems. Normally, LeetCode has two bi-weekly contests on Saturdays, I think. On Saturday, there is one of the Saturday has one regular contest and one bi-weekly contest, and other Saturday has just a weekly contest. So we are going to focus only on weekly contest unless someone suggests that we should do bi-weekly contest too. To start, we are going to go with last week's contest, 175. In general, there are four problems, and most of the time I have seen you will have one easy, two medium, and one hard problem. Sometimes they may have three mediums, sometimes they may have two easy, but yeah, that's how it works. So we'll try to solve these four problems. We'll go through the approaches in, uh, in an hour around that time. So did anyone get a chance to look at the problems?
Yes.
That's great.
Yes.
Very nice. So what we are going to do, we'll start from easy, then medium, in the order they appeared in the contest. So let's try to solve the first problem. The first problem is you are given an array and you have to find whether any element n and its double exist or not. So in this case, and you have to return true or false. So in this case, 10 is there. If there was an element called 20, then I could say, hey, yeah, definitely something like that exists. Or if you see 2, there was a 4, I would say, yes, it exists. For 5, actually, there is 110, so it does exist. So we will return true. Similarly, here for 7, you can see there is a 14, which is double of it, exists. Here, in the third example, there is nothing for 3, like 6 is not there. For 1, 2 is not there. For 7, 14 is not there. For 11, 22 is not there. So that's the problem. And do you have any doubt?
If we are getting like let's say 5 and 10 and 2 and 4, so still we need to return true only?
If we are getting 5 and 10 and 2 and 4, yes. If you have more, pairs, it's fine.
Okay.
Yeah.
And only we are considering the even numbers, right? We are not considering the let's say 11 by 5, that will give the something in decimal, so that we are not going to consider, right?
Right. So from the question point of view, if you think 11 by 5, when you see 11, you are looking for 22. You forget about the division for the time being, because that's implementation detail. But from question's point of view, if you are looking at 11, you are searching for 22. If you're looking at 5, you are searching for 10.
Okay. Got your point. Yeah.
Yeah. So that's the problem. And anybody try to solve it or has approach can come now.
Yeah, so look in this problem, and I relate it to one of the problem we did in the past, which is the two-sum problem. Okay. So this one we can, face this in terms of two-sum. So we have the, we're looking for a double value, right? So, what I'm thinking, I'm going to put it to I iterate to the input and put it into a set. And then, and I look up when I see a value, and I double that and look up the set. If there's such a value in a set, then I return true.
Okay, let's do one thing. Let's go through one example. We will understand what you're doing. Make sense?
Yeah.
Okay. So let me take an example. So the first example, let me search. Is it 10253? Okay.
Yes. Yeah. 10253. Yes.
10253. So let me write that here. 10, 2, 5, 3. So amazing line. What you were suggesting, what should I do now?
It's a mute.
Wait. Okay,
Oh, yeah.
sorry. First, I create a set,
Okay.
and then the first, and I iterate through the input. First element I see is 10. So, I double 10 is 20. Then I look in the set, it's a 20 in the set because the set now is empty.
Yep.
So I put 10 in the set.
Okay, so you got no and you put the
Yeah.
set 10 in the set. Okay.
And I to the next element number 2, I double that 2 is 4. Then look in the set, there's no value in the set. Then I put 2 in the set.
Got it.
Right. Now go to 5, and I double 5 is 10. And now I see 10 in the set, and then I return true.
Okay. Look, so this should work for sure, I think. So,
And what about if we'll take an array element and let's say we are having index I and value B, and we can check that if either B multiply by 2 or B divide by 2 is the rest in the array. So that way also we can check that way, right?
yeah, we will go to that approach next maybe.
Okay.
So for this amazing line, like your time complexity is O of n, right?
Right.
And the space complexity, we can still say O of n, right?
Right.
So the other approach, I think, is it Sukhen, you were approaching this, right?
Yes, yeah.
Okay. So when you were saying put it in an array, I think you still mean to put it in set, because if you put anything in array, checking whether that element or its double, whatever you are searching, will in itself become a like O of n operation, just to search whether something is in the array or not.
Okay. I mean, just I thought so I can share my thoughts. Yeah.
So you are, I think, still thinking to use set, but what you are proposing that, hey, like when I am looking at 10, I will not only search for 20, I can search for 5 as well, right?
Right.
That's so okay. So what will happen in that case? You started with 10, you search for these two guys, and they were not there, so you will put it in the set anyway, right?
Right.
Then 2 came, then you are looking for 4 and 1, right? They were not there, so you will put 2 in the set again. That is fine. When 5 came, then you are looking for 10 and what? Are you looking for 2?
No, I'm only looking for that like either divide by 2 or multiplication. Yeah.
So you are not looking. Yeah, I'm just making sure that you are not looking here for 2. Because that
No.
will be wrong.
Yeah.
Okay. So you are basically looking for this 2 into anything is even. So that's not a problem, right?
Right.
But if we divide something by 2, then we are not sure whether it will be an even number or not. So in case
that's why I'm saying that that will only like even, but if let's say I have 11 by 2, that is giving the 5.5. So that is not integer, right? So it will be only look for the, like if B percentage 2 equal to 0, then only that will be workable. Yes. Yeah. Double value exists. Yeah.
Right. So when you are doing that, you are doing both operation and you check whether if it is an even, then do this operation, like, division, otherwise don't search for it.
Yes, that's correct. Yeah.
Yeah. So that works. And actually that is a better way, though complexity wise it's same, but why it is better? Because you may get your elements faster in general. Right. Because like, otherwise you will put a lot of elements and then that will get paired up later, which you can, get sooner if you do that. So time complexity wise and space complexity wise still same, but like this is a slightly better approach, I would say. Any other approach? Anyone tried or has
Wait,
suggestion?
so on the second approach,
Yeah.
when we put it in the array, then we have to sort it, or
It's not set. It's not array. Sorry, he's still using set only. The
oh,
same thing
okay,
which you were using.
okay, yeah,
Yeah, we talked about it.
okay.
What if the array has an element which its value is 0? If you use a set and put the 0 to the set, but it is the only 0 in the array, so the return result will be false.
So whoever asked this one, that was my next question to ask. So yeah, it's a very good thing. Whenever you are putting anything in an array, in a set, you know, especially with 0, be aware, like it's a special case with set. It will tell you that, hey, I do exist, but if you're looking for an pair, anything multiplied by 0 is 0. But I don't think, is the number all positive or not? I haven't checked the bound of the number. It's actually, yeah, it can be 0. Okay.
Yeah.
Yes.
I think it even if it's 0, it's still working, right? Because what we do is, like from my first approach, I double the value first and then look up the set. So, you know, if this is the first 0, then when I double that, I look at the set and the set is empty. So I put 0 in there.
So the question is, if this is the input, do we return true or false?
We return false.
We return false.
Yeah.
But, oh, okay. Okay. So what we are going to do here, like suppose 3057, what he's saying that, okay, it will work because, you know, you put 3, then when he went to check 0, actually there was no pair for 0. So you put it here. So this guy will only get checked next when there is another 0, right?
Right.
Yeah, so that will still work. I think so. Yeah. So
yeah, okay, it makes sense.
Yeah, it makes sense because we are processing in that particular order. But I really liked the person who suggested that when you put 0 in the set, make sure that you know that you are not, like, you know, pairing it with itself, and that I think you can do it for any number in this particular.
So for 0, we are not getting any double, right?
Yeah. True. Okay. So that's the first problem. Anyone tried anything else, or we can move to the next one? I think we are all set.
Right.
Okay, so we'll go to the next problem. Okay. So second problem is minimum number of steps to make 2 strings anagram. So do you know what is anagram? Anagram is if you are giving 2 strings and you can try different permutation of one string to build the second string, then those 2 strings are anagram, right? For example, in this example, BAB is one string, another is ABA. Suppose instead of ABA, it was BBA, then I could change the order of the characters in T to make it S. So we can say in that particular case, that's S and T are anagram. But in this problem, we know that most likely, yeah, sometimes you will have, maybe they are already anagram, like in third case, but in some cases they are not. Then you have to tell how many characters you will replace to make second string anagram of first string.
Can you please
And
repeat the problem?
repeat the problem?
Yeah.
Yeah. So let me try to explain using on the whiteboard. It's easier, I think, because we can change things.
Yes, sure.
Yeah. Okay, let's clear. Okay.
And what we need to return here?
The minimum number of characters you will change. So suppose your one string was it ABA? I can't see the example now, but anyway, the another is BBA,
Yeah.
right?
Mhm.
Probably this was your source. Like you want to build this one from this one. I think that is what was required.
Okay.
So if you change this particular character to B,
Mhm.
then they are equal, right?
Right.
So that is the problem. Like, what is the minimum number of characters you will be changing in one of the string to make the other string same?
Similar.
Yeah.
Okay. Okay.
So anyone try to solve it or has an idea?
So first, the length of two string have to be the same, right?
First, the length of the two string. Actually, it's given in the problem. Luckily, actually, yeah, it's a very nice thing you remembered. I had forgotten that they are already of equal length.
Oh, okay.
And if they are not equal, then?
In this particular problem, they are saying it is equal, but if it was not, and suppose I had x, 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 I have to delete all these, right?
So if they are not equal, so first we need to make equal, then we start. That you are trying to say?
The two strings length is definitely equal because it is given in the assumption. Yeah.
Okay.
Yes.
Okay. That is given in the problem itself. Okay.
Yeah.
And I think the problem also state that we have to make the second string. We only change the second string so that will match the first string. Is that, can anybody confirm?
What was your question? Sorry, can you
The
repeat?
problem state that we have two string, right? The first and the second string.
Mm-hmm.
And we have to change the second string so that match the first string.
Yeah, so this was T and this was S in the problem.
But
So,
we are changing in the T, not S, right? We are changing T and making as S, right?
that's right. In the problem, it was given in the opposite order. I just wrote it in this order, but yeah.
So my thinking for this would be do the character count, because normally in anagram we must have the same character count.
It's a very nice observation.
So looks like we need to count the both strings first, and then what we can do here, let's say we can go one by one and we count every character in S first, and then decrement the count in the same character, and every time count goes below 0, it means that some other character is missing, and so we add 1 to result. So that is, I can say, if I'm going to write the rest here.
So I'm doing what you guys said. This was your S, right? It had two B's, one A, and this is our T, which had one B, two A's, right? So also you suggested that characters should match the number, because any anagram will have same number of each character, right?
Right.
So somehow now we are saying, since we are one sort of this B, and here we need two B's, we have to add 1B from somewhere, right? Because
Yeah,
we are,
those need to be changed, because first we need to count like every character in S first, and then scan T and then decrement the count in the same character. So every time goes to below 0. Yeah.
okay.
Hey, this is Vivek. A quick suggestion, actually, right? So I think maybe we should just draw out what Sukin was saying. So in this case, if you subtract, after you're done with it, B will be 1 and A will be -1, right?
Yes.
So, okay, let's go through that, like, that two things. So did I build this right for S? That was your first step.
Right.
Okay. So now you are suggesting go process T and then start like, decrementing the count, right?
Right.
So I saw A. So what should I do here? I should decrement the count from 1 to 0.
Yeah, means we need to decrement the account like in the with the same character, right? What I'm saying, we have count every character in S first, right? And then scan T, and then decrement the count in the same character.
So, okay. So your first step is build this map, right? Is that right?
Right.
So we
Right.
did that, right? We are done with that step. Okay.
Mm-hmm.
Now the second step is we are iterating over this guy, right? Or sorry, actually I have written it wrong way. So let's scan this guy, T. Okay.
Mm-hmm. Mm-hmm.
So I did CA. What should I do? We have this map. Should I change it?
Subtract A, so that A becomes 0. Correct.
Right.
Now B
Exactly.
becomes 1. After the second character, B becomes 1.
That's right.
And
Right,
then
Sukhan?
A becomes -1.
So when you see this -1, you think that you are running sort of something. So you do something, right?
No, don't do anything at this point. You're done.
Okay.
Right now, you're done, right?
Okay.
Now, wait up. Just what you see here is that after you're done with this, right, you will find some letters have a positive value, some letters have 0 value, and some letters have negative value. This is what
Okay.
you'll have.
Yeah.
So where it is 0, that is not a problem.
Mm-hmm.
Okay, the sum of all the positives will be equal to sum of all the negatives.
Right.
Always, like if even if you have like A, B, C, D, E, F, right?
Right.
So then, whatever, if you just simply add up all the positive numbers, that is the answer.
If you simply add up all the positive numbers, that will be the answer. Okay.
Or you add up the negative numbers,
or you just add up all these, right? I was looking that way, but yeah.
if you like, whether you add up the positive numbers or whether you add up the negative numbers, or you add up the absolute value and divide it by 2, all these 3 are answers.
Right. Did it make sense to everyone?
Yeah, another method maybe when you notice like the character A number is from 1 to 0. Once the number is 0, you delete that character in your map. And when you meet with the second A, the map didn't have the A character.
Mm-hmm.
Yeah, the -1, this step will not do that. Yeah.
Right.
And at last, you just calculate the positive number of every character in your map. That's the answer.
That will work.
Fantastic suggestion. That also will work, right?
Yeah,
Essentially, what you're saying is every time you now that you've gotten rid of all the A's or equivalent number of A's, any more A's that you want to take away from this, anything that you're not able to take away, you should just keep track of that. So you just keep another variable where you're saying number of mismatches, and anytime you cannot go below 0, you just store that. In the result, you just keep adding. So in this case, you will add, instead of making the 0 to a -1, you will just put it in the result, which is what I think Roger was looking at as well.
Yeah, this is what, like, same 3 ways to do the same logic. Whenever you are running sort of things, you can say it is minus, you can say it doesn't exist, but they mean the same thing. For us, we definitely know that we need something which is missing here. So we are just, increasing the count, and then we will have that as our result, right? Anyone has any questions or better ideas, other ideas? time complexity. Can someone tell me the time complexity for this?
It's big O of n,
Order
right?
of n, right? Order of n, scan.
Okay. And space complexity?
Order
Could
of 1.
be big O of n too, because in case we, oh wait, let me see. I don't know.
So the problem is, do they mention it's all alphabetical, like, yeah, all lowercase English letters only. If you're looking for
Yeah.
that, yeah,
So
Yeah,
26,
constant.
just 26. So constant.
it's a constant. Will you use map or you will use array for building this?
Just array.
Map. I think map is good to search one character. If you use the array, you have to check each of them.
Do you have
No,
to?
you can do indexing, right? So
Oh,
like
yeah,
A
yeah.
will be in 0th
Yeah.
location, E will be in 1, and Z will be in 25. So you should be fine using either a map or
Yes.
an array. But I think in such questions especially where it's limited, it's just preferred to use array.
Yeah, because we have some limited numbers, so we should not be worry about much more. Yeah, but if we have some other, then we have to think something else. Yeah.
Not only that, but I also thinking of using map. You have to write more because you have to remember the API. Check if it exists, and that type. It could be the code would be a bit longer.
It should be roughly the same. I think.
Yeah, the runtime would be the same. I mean, but the code.
Even
I mean,
writing code, right?
Yeah, writing code. Yeah.
Specifically, the other algorithm where we said we will delete the A if it's not there and handle it. You just have to handle array of values equal to 0, then don't subtract and things like that. It's like the if conditions will change, but I think it will be a one-to-one in terms of number of lines. It will be identical. Is what my initial read is. Space complexity, the map might take like maybe 2 or 3x more than the array, but it's still like O of n. So, or O of 1 in this case.
Yep. I mean, we are all on the same page. It's good that we brought up that array thing because map has overhead, but for all practical purposes, go with anything. Just be aware that if you're asked, you know the stuff, like, about like why we can use array in this particular case. A map gives you more flexibility. Suppose like, you don't know which character can come. Your map implementation will still work, but array, you will have a tricky time to get this working. Right? So should we move to the next problem? Or is there any questions on this or any suggestions?
I think we can move to the next problem.
Great. So what did I do? So share a screen. Let's go to the problem number 3. Okay, this is a lot of things we are designing tweet counts per frequency. To explain you, let me first go to the the definition here. So you have to build a class tweet counts. It has 2 APIs. One is tweet name and another is time. Time could be, I think it's minute, hour, and day. Minute, hour, or day. So that could be the time there. It's int. So we'll go to the details soon, but just you understand that for any tweet we have to store the time when this tweet came at, and then you will be asked like this thing, frequency on which granularity, is it minute or hour or day. Tweet name, the same thing which we were storing here in the first case, and start time and end time. So you have to return all the tweets between that time for that particular key and that granularity. So we'll go through the example and it will make more sense. So something like this. You will record tweet 3 at time 0, tweet 3 at time 60, tweet 3 at time 10. And all these are basically currently in seconds. So this means at 0th second, there was a tweet 3. Again at 60th second, there was a tweet 3. And at 10th second, there was another tweet 3. Now, if somebody asks me, like, okay, give me the frequency where the granularity is minute and we are looking for tweet 3 from 0 to 59, I should return 2 because we had tweet at 0 and 10th. 60th is not in that range, so we'll ignore that.
I have a question. You mentioned that it was 0 second, 60 second, and 10 second, right?
Right.
The query was in minute. So 0 to 59 minute would be that, like the interval would be an hour.
So we'll go to that, but yeah, for now, just understand that 0 to 59 means 0 to 60. Let me check. 0 to 60 means 1 minute basically.
Regardless of the granularity, the time is always in seconds.
Yeah.
That's how I read the question.
Yeah, you are storing this only in seconds.
Not just storing, even the start time, end time in the get tweet count per frequency function is also time, which is essentially in seconds. If you look at that, right, in the brackets, it says start time in seconds, end time in seconds.
Yeah, we will come to this in next example. So I will tell you why this is why they are mentioning this minute. So now if they ask you minutes here but the value is 0 to 60, then you are not returning 3 actually. You are returning 2 and 1. So you have 2 buckets of 1 minute here from 0 to 59 and from 60 to 61. See, so 0 to 60, where 60 is not included, you can think it's like 59. There were 2 tweets between that. And from 60 to 61, you will say there is another 1 tweet. So that is the whole point of passing this thing. So you are creating bucket per minute. Think like that. Does that make sense? I will explain on the board, but this is very important, I think. If you don't understand it, we will not be able to derive the actual solution. So this example from 0 to 59, there is 1 minute. And we had 2 tweets in 1 minute time. The second one, the 60 minute, started the beginning of another minute. So that doesn't belong to that particular bucket of minute, if I can say. So you will say, okay, first minute we had 2 tweet, second minute we had 1 tweet. If it was like, we had more tweets at 61, 62, 63, then we will say 3 here. Is that clear? I will wait. If it is not clear, then
yeah, it's not. I'm trying to digest it, but it.
Okay, let me draw it then. That will make we can have our own example in that case. So in the first case, we had tweet at 0 and 59, actually 0 and 10. Let's say it is 10 and 59. Was that? But if not, then anyway, suppose. So in this minute 0 to 60, where 60 is not inclusive, we had 3 tweets, for example. Suppose we had tweet at 60, 62, 65, 120. then we can say that from 60 to, let's make it 120, where 120 is not inclusive, we have another 3 of this. So now if the problem asks, okay, give me the tweet from 0 to 120, then I'm not returning 6. I will check, okay, how many minutes are between 0 to 120. So we'll say, okay, there are 2 such minutes. First is this one. So I will go and check, okay, how many tweets were in this particular minute. So we can go and check, there is one, and there is one. So, okay, in the first bucket, return these 3. Do we have to fill another bucket? Oh yeah, we have, because there is another minute. So again, how many in this minute? So this guy, these are the valid guys in these. So we'll again have this 3, and we don't have any other bucket to fill. So we'll return these 2. That is the API we have to design.
Yes, it's clear to me.
It clears that out. Okay. So 2 things, they will tell you, okay, the tweet name could be any string. So they were calling it tweet 3. So let's call it tweet 3. So tweet 3 came at 0, tweet 3 came at 10, at 59, something like that. So you are first storing that somehow, and then you are returning that in this particular format. So these 2 APIs you have to design. How do we do that? That's the problem. Any problem? If it is not very clear, please ask, because I looked at this problem and a lot of people didn't like this problem for some reason. So maybe it was not very clear, but this is how I have understood it. And if the problem is clear, can anyone suggest any idea what we can do?
So I did it using tree map. So essentially a balanced binary search tree. So
Okay.
every time a tweet came in, so I kept a hash set with the tweet name and then a tree with it.
Mm-hmm.
And every time an entry came in, I just inserted the entry into the tree map. So they were already logically ordered. And whenever I used to get a query for getting the tweets and balancer in the the sets, I used to first, based on the frequency type they are requesting, create batches. And then for each batch, I used to query the tree to get the sum. Like if I have, and the tree used to contain the time of the input and how many queries, how many tweets were created at the same time.
Okay, so what Puneet is suggesting is what he did. This is suppose tweet 3, right?
Roger, before we go into that, right, I wanted to ask one macro question here. So, Puneet, are you trying to store like the number of tweets on a per time basis, like for always, or why are you doing that? Why are you storing everything?
So suppose that you have a tweet 3 coming at time 10, and you had tweet 3 again coming at time 10. So I was just trying to store the number of frequency of tweets at the same time also. Like there were 2 simultaneous tweet 3s pushed at time 10.
Got it. So you're not storing all the tweets, but you're only storing the count, but the granularity you're
Yes.
storing the count is at a timestamp level, right?
That's correct.
Which means that if a tweet, if like 20 tweets came at 0, you'll store a value of 0 corresponding to 20. And if like 50 came at 1, then you will store the value 50 corresponding to 1. Correct?
So
Even though the request is always at a minute level, it's never at a second level. Why are you storing this level of granularity?
Because I'm not sure in future, because that minute query, the queries are coming in future. So I don't know whether they will come at minute level, hour level, or day level.
No, the frequencies are given, right?
Right, but there are 3. The lowest level is second.
Is it? I thought it was not. It was like a minute, hour, and day. Let me just read the question again. Maybe I read it wrong.
Just let me also do it.
Yeah, there are three actually: minute, hour, and day.
Yeah, it's not seconds.
Right. So I understand. The problem was the minute start time is not known. So they can do a minute, but it can start from like 13th time, right? 13 and then minute frequency is like 13 plus 60. That's your batch.
Exactly. That is a nuance I wanted to call out. So the reason why I asked these questions was that the thing is that so example that Roger has written right now is that if you say that I want 1 minute and you start from 0, then the aggregation is different, and if you start from 1, then the aggregation is different, right? The answer will be 3,1 or 1,3, depending on whether you start from the minute 1 or not, right? So you have to store data at a minute, at a second granularity. That is clear. There is no other way, correct?
Exactly.
Yeah, I think.
And now the next question was your choice of data structure. Why did you pick a tree map?
So essentially, I'm trying to have this as a balanced binary tree, so that my every query on the tree is a log of an operation. I don't have to go query everything and then calculate it from the start to end. So I can just query it from the start of batch, get the result, kind of segmentary range query, and then end and then sum it up. I know it will not be a perfect solution, but yes.
The concern I have here is, what if I have like 1 billion tweets, and those tweets are all like in different, not exactly completely entirely different, but what if they are actually clustered into maybe like 100,000 entries or something like that, and but they are all like multiple. So each tweet, each timestamp will have like maybe 1,000 events or something like that. So you will be spending an n-log and complexity doing the insertion.
Right.
If you use a tree map.
Right.
Okay, so I think you need to think a little harder in terms of the constraints of the problem. Is that you want to store like a straight up map, or you could just store the whole thing in a straight up map. Then the lookup complexity is harder, right? The lookup is essentially when you're doing the lookup, you will be running through the entire thing.
Exactly.
You can do that. I was trying to. Yeah. So which one is better? Do you want to take the hit at the insert, or do you want to take the hit at the get?
Right. So I assume that the queries were a bit lower than that, because if that's the case, probably then I have to change the data structure for storage. Then if the amount of the tweets or the batches are smaller, I can probably go it with a simple sorted array, and then query it over there. That will be much faster as if the the tweets are higher as compared to the recordings.
Right. There are only 100,000 operations here. That's the question. Like if I read the questions, right, it's 10,000 operations. That's it, including both record tweet and get tweet. And
the frequency of each of them
time difference is also not much. So I actually don't see a whole lot of concern in terms of using either approach at this point of time, because even n-log-n is like it's a very small operation. So either is fine. Pick the one that actually gives you the most value. So your tree map is fine, or the other one. So I just wanted to let everyone, just point everybody's attention to, there are two different ways of solving for it. One is using a tree map, which essentially makes the insertion a little bit more complicated, because you have to do a find every time you do the new tweet thing. But then the retrieval is actually a little easier, because you can actually just go down the tree very quickly and get that. Whereas the other one is where the insertion is actually brain dead simple. You just copy paste, you just put it in a simple hash map. But then the retrieval is more complicated, because you have to iterate through the whole thing. And that's that. And you could probably do something a little bit more cleverer, but that's about it.
So with the tree map, you still need to find the start time and the end time, and then you accumulate the value in between, right?
When you
Correct.
say
so what we do,
Yeah, go ahead.
What you do is you find the start time or the value that is just immediately greater than start time in the tree map. Okay. Once you find that, you can always go to tree map's next element. Tree map actually gives you a way of getting to the next element. It's an ordered hash map.
Right.
Right?
But in the worst case, we could travel the whole tree, right?
No, it won't, right? The finding an element in the tree map is actually log n.
No, I think what he's saying is if you are querying always from the minimum of tree to the maximum, then you will have to, iterate over the entire tree to get the sum.
Yeah.
Right. So I think what he's saying is making sense, but considering a scenario where, it will always calculate start to end, it will go to a O of n operation.
Correct.
So essentially what he's saying, yeah.
That is correct. Yeah. The worst case complexity is actually O of
N
n.
square.
Yeah, so fair enough. So both operations, both logic seems to make sense. So can we just go take a look at the tree map approach first, and then maybe do the hash map approach as well quickly?
Sure. So since we are talking about tree map already, and we talked a little bit about it, this is the structure, like a balanced binary search tree kind of stuff. So most of the operations are in O of log time. And so if you have been given a range, like a start time and end time, you don't actually have to go at every place. You can just figure out things in logarithmic time, and you only care about that time. You will be able to get the overall result. Once you are able to get the overall result between, for example, somebody asked me between 10 minutes to 50 minutes, and if my granularity was minutes, then suppose I have all these results got from here already, then I have to, just for output, I will try to put it in different buckets, right? There will be like maybe 10 to 50, maybe almost 40 buckets. I will fill one by one, and I will be asking my tree map, hey, now give me the result for the next one. And I know which bucket to pre-fill, right? That's the approach, Puneet, you did, I guess. Puneet?
Yeah.
Yes, right? So that is how we filled it and we returned it. And I already explained it when you guys were talking, is this is how we are storing. We have a map of this key tweet, and it has this tree map as the value, which has these counts, like, at 0th second, we have one such tweet, at 10, we have two such tweets, and at 60, we have these one. So that's how we started to store it. If we don't do it that, okay, for the time being, is there any problem or any questions on that particular approach? We already talked about it. We talked about a little bit about complexity too. And why it is good is because here retrieval is easier, because we are doing, whenever we have to do range query, tree map or any sorted data structure should come to your mind from intuition point of view. Whether that is the best or not, that again depends on, since we are not just retrieving, we are also putting stuff, depends what we want to optimize. If it is a very read heavy system, then maybe yes. If it is a write heavy thing, then maybe just using a Haz-Map makes more sense, as we were just discussing.
Yeah, one quick thing as well on top of this, right? So one of the ways you can actually optimize the retrieval as well a little bit by having like the tree itself, right? In addition to containing the value for the node, it can also aggregate everything in its children.
Yeah, here, like you can have here things, right? Don't go below. You are saying that?
Correct. So if you are covering everything from the minimum end of the tree to the maximum end of the tree, then the tree node itself, that particular root node itself, should contain the summed value of everything underneath it.
Yeah, but would that make the insertion a little bit more complex, because we need to traverse to the root and aggregate the value I guess it's 5 because
won't,
it
right?
depends on the
Because
height of the
No,
tree.
it will be actually faster because then you are actually combining two aspects. You are making it a binary tree as well as a segment tree. So you don't need to go down to get the values. It's already
Let's talk about,
pre-aggregated.
let's confirm the insertion, right? The thing was that since you're doing more work during insertion, the question was, is it making the insertion more complex, or is it still the same complexity time-wise?
So whenever you do the insertion here, now you have to maintain this also, right? So it will again, like, try to make sure this order is preserved. So it is getting slower for sure.
From time
It won't be
complexity wise, it
slower.
shouldn't be because you anyway
Yeah, it
are
won't be
going
slower.
down. Sorry, go ahead.
The act of actually registering a tweet before we made this change was log n, right? Because you had to go down to the depth, find the right location, increment the value. So it was log n, correct? Now what you have to do is, as you're going down the depth, right? At every step, you're incrementing the value. There'll be two values you're storing. One value is value of the node itself, and the other value is value of all its children. Okay. So as you're going down the tree, you're just adding the value of children number, and then you keep going down. So you're essentially doing 2 times the operation. So which is 2 log n, which is still the same as log n. So this is like essentially storing an order statistic, which keeps the number of tweets for the current timestamp, which is the node value itself. And the second one is essentially for all its children. Now, as you read through it, if you're able to get to, I mean, you will find, if the current node covers the entire child, then you can just read the value of the current one. If not, you just delegate the responsibility to bottom one. So in theory, it's like it's a little bit more if you're looking at very tighter time complexity numbers, like because the constant values and the multipliers are different. But in the bigger terms, it's the same. It's just log n. Does that make sense?
Yes, it does make sense. So yeah, I was thinking in that direction that yes, of course, complexity is theoretically same, but practically a bit higher because it has to do more work. I mean, that is what happens when you apply more indexes in your databases, because yes, it will now start doing more work while writing, because to give you a faster read query, earlier you had just indexed in one column, for example. Now you have 3 more columns you're indexing at. Exactly same thing happens in that case, right?
Right.
Just to give you the faster read, now it will start putting stuff in this particular sorted structure so that it can return things. So in the faster time. So exactly same thing applies there. And that's why our read starts to become faster, but the writing takes hit. And that is the reason we don't apply index on all the fields unless we require. Does that make sense?
Yeah. And I think right now it's based on the granularity of the second, right? Suppose if they want to query in the interval of hour and interval of day, would that the time complexity be the same, or can we improve it?
I mean, time complexity will be the same. The only thing is now you are going to fill more buckets, right? So worst case, we are already thinking about the worst case when someone is asking you from start to end, right? Think your query is okay, return me everything from the beginning till the end of the time interval.
I'm asking if we have a way to improve the time complexity when the query hour or day.
Oh, I think what you are saying that if we can pre-compute on hour level or minute level and just start using that, if the whole bucket is filled. I think Vivek already talked about that approach where he was saying store that here. So that will be an optimization already.
Like right, for every number, you're actually you're storing there, but you can, but there are like significant amount of concerns with that. So I think technically you can create like 3 maps One gives you the minute value, one the day, and the one the hour, and you can just insert the same tweet thrice in that. So essentially saying from any starting point looking forward, you can do a bunch of different things with that, but the challenge you will run into is that I think you're now talking about a whole lot of space and a whole lot of time for insert, while you are not really benefiting. I mean, the read operation can be simpler later, but it's not really that big of a deal. So I would just, this is like the middle ground where you are keeping the order statistic along with the value, so that way the tree is covered. So at a at a second level, you know what the value looks like, and you're just doing an aggregation for minutes, day, or hour, depending on whatever you want. If the question had been a little more tighter in terms of saying that if I'm asking for minute granularity, I will always ask it based on the start of the minute. If it was not start timestamp and end timestamp, but it was actually start unit and end unit. So if they had said that it'll be minute, start minute and end minute will be it'll just be always like, zero aligned for seconds, then you have some opportunity to do a little bit more compression at that point of time. Right now, not really. So I think in the interest of time, let's actually move and do do you want to do the hash map thing? But I think it's the same concept, right? Except that instead of tree map, you're just putting it in a hash. That's it. You're just counting all the elements and that's about it. It should be very straightforward. I looked at a few solutions that people have written, and looks like most of them have used the Hashmap solution.
Oh, I see.
Because tree map is complicated to implement, right? I mean, you have to think about it. Either you have to use inbuilt functions or not. Hash is like easily available, and you can just go ahead and implement it pretty straightforward. If you look at any example, you can click on the code link, which is in the table of the rankings, and you can see people have taken about 10 to 20 minutes typically to solve, and most of them have used a tree map based, not tree map, a hash based solution.
I see. Okay.
I had to in fact learn tree map to solve this, because I usually code in C# or Java, and they don't have any inbuilt the binary or avial trees.
So Java had tree map, right? So it gives a lot of things there. By the way, like since we were talking about Haz-Map, and we always think about the complexity is O of 1, I will take 2 minutes to clarify one thing. So, hash collisions, if there are too many calls, it may turn it into O of n, right? Some of you may already know that. So I won't go into that too much, because of internally it will start having this kind of linked list where it has to start searching, and then if your hash function is not good enough, or if you have too many collisions, this will not be a very good time complexity. So what Java's Hashmap does, it will give you O1 up to certain time, and after some time, if the size is too big, it just converts it to sorted structure. So it will start giving you O of log. This is like internals of Hashmap. I just learned, so I thought I will tell you. So in theory, we will say O of 1, but they change the implementation after some time, after a certain threshold, that, hey, just convert it to log implementation, because they know that it will give you a better result. I may share that screen, like that link maybe later if I remember, but I did read about it a couple of years ago, 2 years back, I guess.
Okay.
Okay.
Can we quickly go over the second approach?
The Hashmap?
Yes.
Okay, so let's do that. So here we have the same thing. Here we have Hashmap, and so put anything is very fast here, right? Write is fast here, because that this is giving you O of 1 time to write, for sure, right? In theory. The problem is when you have to return something from start to end, suppose your time starts at 0 and ends at 40,000, for example. Let's call it minute or whatever. And the granularity is 40,000, for example. So you have these many buckets. Now, how would you fill that? You will go one by one, right? You will look into, okay, here, let me zoom it a little bit. You have this, oh, actually I already have it here, this side. So here you will say, okay, 0 falls in first bucket, okay. 10 falls in, you will also look for 1 because you don't know what you have. So you will go check on the first second, second, third second, and finally you will find something on 10th. So you will go through each possible values for all the queries, right? So you are scanning this way. For each read query. In tree map, that was giving you already values between some start time and end time. It knows about that because that is how it was implemented because of the sorted nature. And the question, if it was from T1 to T2, then you will go from here. Like suppose this was T1, you will start from here, you go down, start accumulating your result, filling your bucket, and then just return the result.
This is the hash table, right?
This is the hash table. You can think it as a hash map.
Okay, yeah. It's not order. So I still need to go first, I mean the second by second and look it up.
Yes, and it will go second by second.
Good. Okay, I see.
All right.
Okay.
We are done with this. I
guess.
Yes. Okay. Let's go to the last problem for the day. Okay. How do I? Okay. So here you are given a grade. Actually, this is a class where students can take exam, and cross means that these chairs are not good. So I think that's what cross means. Let me check. Yes. And dot means that you can sit on that. Any student could be seated there. It's a good seat. But the problem is, one more restriction they have added is that this guy can cheat if any person is sitting here, here, or diagonally in front of him. So you don't want to have such an arrangement. So given this arrangement, what is the maximum number of students which could be placed there? So in this particular configuration, you can see, yeah, nobody can cheat here, right? This guy can't cheat because no one is sitting here. If there was one guy here, then this arrangement is not a good one, because this can cheat from him, and actually this guy can also cheat from him because it is also in a diagonal direction. Another guy just in front of him is there. So the problem is, you have been given this configuration, you have to return how many maximum students can take the exam, and the bound is m and n is just 8. So you will have a maximum of 8 students in one row, and you can have maximum of 8 rows. That's the problem. Any question on the problem? Is it clear? Or we can draw.
Yes, it's clear.
Okay.
Jimmy.
Okay. So, okay, let me stop sharing. Let me start sharing the screen, and then has anyone solved it, or I will take 1 minute break, and then please continue the discussion. In the meantime, if somebody has the ideas, please go on.
Yeah, so I tried it using backtracking, similar to the other standard and queen end problem. Unfortunately, it fails some of the test cases in lead code with TLE, although it completes on the local machine, but the lead code, according to lead code standards, it fails some of the test cases, especially the ones where we have 8x8 metrics and a lot of free spaces to play with.
Is it fail or like exceed time limit?
TLE, exceed time limit.
Okay, backs. Sorry, guys. So, what's the idea so far? Have we discussed anything so far? No. Okay.
Yeah, I just mentioned that I tried with backtracking, but for some other cases it is failing with time limit exception.
Yeah, time limit. Yes. So to simplify it, there are a couple of things. Let's make it very simple that chairs are not broken, for example. Like everything is fine. Anybody can sit anywhere, right? So suppose all these points are valid. And we have to give a arrangement, like how many students can sit with the same rule. So there is some rule. Let's don't go into that detail, but yeah, just for understanding purpose, this is not feasible. If you want to sit a guy here, you have to make sure that you have no one here, you have no one here, you have no one here, you have no one here. Okay. And then on top of that, we have these things like you can't use all these seats. So that makes it even one more reasons that you can't choose a seat. So what are the choices for a student? Like if you had no restrictions, for example, what can you do? Like either you will seat a student somewhere and on IH seat or not, right? So if you choose to seat a student, then you have to take so two things we have to think. For any student what I am saying, okay, let's assign him this seat. So I made a decision that, okay, some seat got assigned, seat assigned, for example, to that guy. So once you make that decision, then your board configuration will change, right? Because after that, now you have a different set of board, whatever the rules were, because if you chose this particular seat, now you have to make sure that this seat is not valid, right? And this is not valid. Also, while sitting this guy, you have to make sure nobody is sitting here. So you can also make these guys invalid and make sure that no one was here. If you are going from top to bottom, you can do that. Or you are saying, okay, I'm not, choosing that particular seat. So that is left. So when you are leaving that seat, then your board configuration is not changed. Is that right?
Right.
Board not changed. Though you may wish to change to make sure that you made that decision that, hey, make sure that we don't choose it because, in your recursion, you have already made that decision for now. So you will go through all these possibilities and then finally you will see, okay, how many students were able to sit. That is one approach. I think if you think about the board configuration, we have something like 8x8 board maximum. So, and these are all, I think, characters, something like this, or dot, yeah, things like that. You have this kind of thing. So somehow you have to represent that board. And in your recursive call, you have to keep passing that board all the time with the new configuration. So in that approach, at least what I was thinking, maybe Puneet may have optimized it a bit, but this is the basic brute force, is that we are not leveraging the idea that any row depends on the guy above it, right? This seat, like, this row doesn't depend on the first row, but it depends on the second row, right? Questions, guys? Any question, please ask now.
Yeah, that's right.
So the first approach where we are not leveraging this will still work. The only thing is you may get into the time complexity problem, because we are looking at the grand state of the system and then we make the decisions. And for each seat, the maximum number of choices you can make is 2, right? Whether that seat is chosen or not. So if there are these many seats, you make that decision 2 for all of those guys. And then you again try to solve the same problem. So if I chose this guy, I still have to, find the solution for this configuration again and keep a global maximum when I finally reach what was the maximum student I was able to put on the board. So to optimize it, this is one thing which we have to use somehow.
Yeah,
So we only need to remember the previous row.
Mm-hmm. We have to. So my ith rows will depend on the for sure, the row above it. Like what was the city?
Not just the row above it, but the state of row after considering the previous row also. It's not just the state of the row, because the state of the previous row might have changed because of its previous rows.
Right. So, okay, let me put it here. Actually, that's a very good point. Not only that, that is making it even complex. So draw this. So if there were only, suppose 3 seats here, how many decisions we could make on this particular, okay. So we can make 2 to the power 3, we can make 8 decisions in the best case, right? Either we sit all the guys here. I know this is not possible because of the restriction of the problem, but in theory, we can have all seats here taken or no seat taken, right? Or 0, 0, 1, like all the binary, values for each seat, right? Each of these 8 seats can give a different solution here, right? That's what Puneet you were talking, and that's a very nice observation.
Right.
So in this particular case, we have 64 maximum such, right? Is it 64? 2 to the power 8 is how much? It is 128 or 256? I think 64 into 4, 256.
256.
Yeah. So for each row, we have these many possible states. So that is one thing we have to be careful, so maybe how would you represent? So your equation may look, if I is your row, maybe I is your this guy. Let's go take a random one somewhere. I is this guy. You will have these values from 0 to 256. Based on this, we have to determine the next candidate. I'm not sure whether which one, maybe 127 gave the best result for DPI plus 1, right? And we again have the same thing. One of this guy will have the best, like maximum number of students sitting. So yes, our one dimension is this one, like let's call it something, let's call it max states. So
could I ask a quick question?
Yeah,
Could
go
you
ahead.
explain again why do we get 2 to the 8, not 2 to the 3?
Oh, so your problem has this value, the maximum number of rows or column is 8.
Oh, okay.
So 2 to the power 8. Think it.
Okay.
I think he got confused with number of ones you have drawn.
Yeah.
Oh, sorry. Yeah. So what we are trying to derive is possible solution based on this observation, that this value depends on previous all the possible states, right? And on top of that, whenever we are going to choose something, we have to make sure that we know the configuration for when this was a successful valid case, right? So you have to also make sure that you take care of the rule while deciding this thing. That is, the rules are easy. Rules are not very tough. So like for simplicity, like first try to derive the formula, and then we can talk about rules if we have time. Sounds good? I think so. Okay. So let's call it, let me clear this I think I should be able to clear everything now. We know this, we know this. From here we are deriving this. This was the I, and this had say 256 configuration. Let's call it J for the time being, as we do. This is I plus 1. This is J, for example. Can anybody suggest a formula for this? TP I plus 1 J is equal to what in terms of ij? Like you can consider that not I plus 1, let's call it I. Yeah, it's fine. Like in terms of the previous guy, that's what we care here. You remember that anyone can give you a good result here. Any one of this can give the best result. So you have to, you don't know which one. So from 0 to 256, maybe 126, as we were saying, gave the best result, for example. But you don't know. So you have to iterate on all these possible combinations. So what you can say, hey, maybe I should calculate from this K, which can go from 0 to 255. It will iterate on that. It will find the best result, which is possible. And then we will apply our rule and, get the best, say X is the new number of seats which we could fill here. So we can say X. Now K goes from 0 to 255. And we have to choose the best out of it. So let's call it max. And X is let's call this guy the valid seat on ith row. But this guy also depends on what value was chosen for this configuration, because whatever was the configuration on top of it, so that changes this value. So while you are doing that, you are going through that, you apply your rules, figure out the best number here, and you keep a count of this value. This is the best result you can get. Does that make sense?
I have a question about the X value.
Yeah.
The X is the valid seat on the ith row or I plus 1th row.
You are right. I made
Yeah.
a mistake. I plus 1th row, this last row, which we are considering.
Yeah, that's the row we know now.
Yes.
But the ith row we also iterate and
Right.
have the fixed value. Yeah, thank you.
Yeah, thank you for clarifying. So, anyone has any questions on at least this formula? No, I think. Does that make sense a little bit at least? You know more, you know the things roughly at least. That, hey, I know I can't implement, but I know something about it. If that is good, then if you spend some time, you will be able to figure out. But do you know how to, like, what we are talking about? If it is totally not making any sense, please ask now. I should be able to clarify.
Can you say what X again?
So the X was, so you have something, some results here, right? Previous result. Your new result is building on top of the previous row's result, right? So in this new result, what problem you are solving? You are sitting couple of students on this last row, right? The row which we are considering, for example. Maybe I chose to put one guy here and one guy here, maybe. So whatever was the best result I got here, I would say, or maybe whatever result I have getting here, I will say +2. So if it was 10, then I will say, hey, if I choose this guy, which was say like 54th cell, so I can say, okay, if I was choosing the 54th row from the top, like, 54th state, let's call it I54, it had value 10, for example. If I choose this one, then it allows me to choose two more candidates. So my I+1, and it's all DP, and maybe this current configuration is maybe 54, I don't know, is 10 plus 2. I can say, okay, I have a solution which can give me 12, but maybe if you choose something else here, you are able to sit just one guy here, for example, suppose I can only fill this one. In that particular case, whatever was the best value on the top row, maybe that was already 20, then 20 plus 1 is 21, is still better. Make sense?
Yes, but then, I want to know what condition that we say that two extra seat can be used for the next row.
Right. So that was the rule of the game. That was given in the picture. I don't know if cross means anything or not, but let's see. If I'm trying to sit some guy here, I have to make sure that someone is not sitting here, right? I have to make sure that I can't sit anyone here.
Okay, yeah.
Right? So all these configurations which you already have, we were representing by, when we are saying 256, basically they are binary, if you can think. So you can see 1010 means that we chose this seat. So somebody is sitting here. Nobody is sitting here, but someone is sitting here. And we have all the possible such combinations already calculated to derive the next best, result for the new row. So we have to go and check all the possible best solutions from the previous row to get the result from the current row.
Got it. And you would check it by is you use a binary operation to check it, or you just look at the string or bit?
So that is where, like, if you know bit and you understand how to do the, like, normal operations on bit, it makes things easier in couple of ways. First of all, storage becomes very cheaper, like, because for example 256 states, one int is enough to just store it, because one int is how many bits? 31 to 32. You just need 8 bits, so you can just have one int to store all these possible states. Plus, if you know how to use bit, you can calculate these things using bit masking. Like, whether like, a neighbor here is sitting or not, what you will do, you will just binary shift your current state. So if I have this combination 1010, if I binary shift it towards right, for example, what it becomes? 01.
Yeah,
Right?
got it.
So like that, diagonally also you can do it. So being familiar with binary manipulation will help you to optimize it more and more.
Thank you. That's clear to me now.
Okay, so that's actually a good problem. And anyone has any questions? I think we have spent quite some time on this, but it's a complex problem, especially like, with all these rules and states, and you may have to go to bit route to maybe make it actually finish the, like,
I'll have to try this bit thing. Because I tried with the normal approach, it really happened. So I'm just going to try it with this bit approach.
right. Yeah, because if you put it in a string, then if you are searching anything in a string, it will be slower than doing it like in a bit, using a bit. So yeah, it will make things a bit slower for sure. So anyone has any question? I think, is there a limit on the recording? Let me check. There is a chat. Let me check what was on the chat. So in chat, somebody was already talking about the bit representation. I'm seeing it now. Luckily, we already went through it a little bit.
I have one question. This is funny. So when you say like we have the representation of bit in the array form, so how are we going to check the validate the condition? You specified some x, because x is the condition, right? So basically, the next row should not match this particular condition. How are we going to validate in that next row operations when we are iterating through that another 250 next to 256?
Okay. So what was the question is like, let me share the screen again. So the question is, if we have the state for this guy, ith guy, right? 128 or 256, right? So you are asking for I plus 1, how would you run the rules, right? Is that the question? Is that the question? Am I mute?
Yeah, yes, correct.
Okay.
No, yes, correct.
Okay. So how would you run that? So you are basically saying, if I am selecting this particular seat, how would I know that somebody is not sitting here or here, right? Is that the question?
Yeah, correct.
Okay. So when we are representing this guy in the bit format, it is basically like, if I'm saying this, this is, for example, let's make it up 0, 0, 1, 0, 1, 0. It's only 6 character, but just to explain. So this will be represented as 2 plus 8, 10. So in your state configuration, this will be the 10th guy when you are iterating. So when I was saying I things, this is your 10th configuration. And when we are working on this particular one, I will check, hey, for this one, I can do some bit manipulation to determine whether there is a valid I here or not. So what you need to know, how you check the set bit at a given position, set bit at I. There are problems on that. Actually, there's a basic questions, we can discuss it, but you can think like, how would you determine anything like that? You can make a mask of 1, and you can, continue shifting it here, 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 and you will do a AND. So if you do AND on this and that, it will tell you there is a 1 here, because all the rest will be 0. So that is one thing to check whether 1 is there or not. Also, couple of things which may help is that, like what I was thinking, that if you know a configuration, for example, if there is a superset of things, and if you need to find whether a configuration is subset of that or not, you can do that on using bit manipulations too. As long as your I, for example, let's call it valid I, this is suppose, and I have created a new configuration, suppose J, which is another configuration. If I do an AND on that, valid I and J, and if it returns me J, what does that mean? That all the possible bits which are set in J is also set here, right? Then only you can get the same guy if you AND it. So there are a couple of these bit tricks which you do some experiment with, and then if you have doubts, post it in our channel. I will try to give more examples if it is not clear.
Okay, yeah, I think it is give some pointers. Thank you.
Yeah.
So in this case, we the space complexity, like you mentioned, it only depends on the previous row. So we only need 1-dimension array, right?
You need 2 dimensions. One I is for sure, there are all these rows, and then you have all these states which we are calling 256. That is another dimension.
But
Yeah,
we don't look back the pre. We don't. We only need the previous row.
We don't just need previous rows, because we have to. Oh, but yeah, that is still 256, right? Yeah. But you still need the board, right? It was given to you to begin with. So you are not considering that the space.
Are we using the DP for the DP would be a new variable, right?
Yeah. So your DP was the number of rows. If the number of rows was, for example, M, you can say, okay, DP M is the maximum. And then your second dimension was 2 to the power number of columns, right? That is for just for DP array.
Okay.
Anyone knows about what could be the time complexity? Because that is more interesting now. Since we have gone through it, we have the formula.
I think it will be big O of, it will be constant, because the dimension of the ball is 8 by 8, and for each row we're gonna iterate through 256, right? Which is also constant.
Yeah, if you treat it like that, sure. So m rows, n column. So what we were doing is for sure m into, we had 2 to the power n state, right? 2 to the power n, and then we were iterating it for all the states. So into again 2 to the power n, I guess. So it will be something like this. And of course, since you are considering these to be constant, so in theory, this all is constant, right? Let's say 8 into 2 to the power 8 into 2 to the power 8, something like that. But yeah, make sure we think like this, because sometimes they will say, okay, I want it in terms of m and n, then something like this make more sense. So do we stop the recording now? We can continue this afterwards, I guess.